to the video on trigonometric functions. So we're going to start with finding the derivative of the sine graph. So of sine. Alright, so when we have our function being f of x is equal to sine x, let's see what that looks like first of all. So we'll draw that here. So we have our x and our y. Here's pi over 2, and then we'll make this pi. This is 3 pi over 2, and then we have a 2 pi. Okay, so sine starts at 0, right? So sine at 0 is 0, and then it goes up, and then it oscillates between -1 and 1, right? So it'll reach its peak at 1, or at pi over 2, right, for our x, and then it'll come back down to be 0 at pi. Okay, so something like this, and then it'll go all the way down to -1 at 3 pi over 2 and come back to 0 at 2 pi. So it looks like this, right? That's our sine graph here. Okay, so now let's look at the tangent line. So the tangent line at 0, the slope of the tangent line is very steep, right? And it's actually going to be 1, okay? And then at, so now I'm going to graph the slope on the same graph here, okay? And then, well, actually, I'll graph that on a different graph so we can see it better. So here's, so this is our f of x graph. This is equal to sine x, right? And now, on this new graph, I'm going to graph the derivative of sine x, and we'll see what that looks like. Okay, so we have our pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so like I said, our slope here is going to be very steep, and it's actually going to be a 1, all right? So it's going to start up here at 1. So this, again, this is our f prime of x, okay? So here we're looking at the slope of the tangent line at each of these points. At pi over 2, the slope of our tangent line is actually 0, okay? So it's going to be 0 here, all right? And then at pi, let's see the slope, it's actually going to be a negative value, and that'll be a -1, okay? So down here. And then 3 pi over 2, again, the tangent line levels out, so the slope of that is 0, so it's going to be a 0. And 2 pi, at 2 pi, it's going to be going up again, just like where we started, so that would be at 1. Okay? So here, this is actually going to graph something that looks like this, okay? And this should look a little bit familiar, right? And this is going to be, this is actually the graph of cosine x, okay? So what we just found, this is a pretty big discovery, or significant find. So the derivative, so d dx of sine x graph is going to equal our cosine x graph, okay? So the derivative of sine is cosine. Alright, so now let's move on to derivative of cosine. So derivative of cosine. So some of you out there might be thinking, hey, maybe it's just sine x. And you're very close, but let's see what changes here. So let's graph the cosine graph first of all. So we have our y and our x. Here's pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Okay? So something like that, right? And our cosine graph, again, it goes between -1 and 1, but this time it starts up at 1. It goes through like this, like so. So here I'm just graphing the cosine graph that we all know and possibly love. That's debatable. But anyway, so here's our cosine. Looks like that, kind of going in a valley here. Alright, so that's one cycle of the cosine. And now let's see, so this is our f of x is equal to cosine x. Alright, now let's put it, let's graph the slope of the tangent line at each of these points. So here's our 1, and here's our -1, and we'll put pi over 2, pi, 3 pi over 2, 2 pi. Okay, so something like that, right? So 3 pi over 2 goes here. Alright, so let's look at and see what happens. So at 0, when x is 0 on our cosine x graph, our tangent line is actually something like this, right? And it here it doesn't look complete, but if you keep cycling through, it'll look like that. So anyways, the slope here, starting at 0, is 0. So that's what we're going to put for our f prime of x. Remember, the derivative is the slope of the tangent line. Tells you that at every single point, right? And now let's look at the slope at pi over 2. That would actually be a negative slope, and this is the steepest negative slope we're going to get. So that's a -1. So we have a -1 down here, all right? So we have a point there. At pi, our tangent line looks like this. So again, it has a slope of 0, so we're back to 0 here. And then at 3 pi over 2, we have a positive slope. It's pretty steep, So that's going to be go all the way up to 1. And then back at 2 pi, our graph will continue like that. And our tangent line, again, is going to have a slope of 0. So if we connect these dots in a smooth fashion, it's going to look like this, okay? And this should look kind of familiar. But in this case, it's not going to be the sine graph exactly. It's going to be the negative of the sine graph, right? Because here it goes down instead of up like it normally does. Normally it would go up and then come down like that. But in this case, it's opposite. So we have that negative here. All right, so our finding on this slide is that the first derivative, the ddx of cosine x, is equal to the negative sine x. Okay? All right, so great. Now, what I'm going to do is go over derivatives. So derivatives of other trig functions. Trig functions. Okay, here in this one, I'm just basically just going to list what are the derivatives of, like, for example, we'll start with tangent x, okay? So the derivative of tangent x is simply going to be secant squared x, secant being 1 over cosine, so this is like 1 over cosine squared x. Okay, and for this one, I'm not really going to go into too much detail, or any detail really, of like why this is this. I think that sine and cosine were pretty complicated themselves, so and these in your book, I believe they're just listed, or they might have proofs in the book, but anyways, the bottom line, I'm just going to list the formulas and like what are the derivatives of what, okay? So this is the derivative of tangent, that's going to be secant squared x, and the next one, I'll just list it here, so ddx of cotangent x, cotangent of x, so that would be, cotangent is cosine x over sine x, okay? So this is going to be a negative cosecant, I can't write here, it's cosecant squared x, okay? The next one I'm going to do is ddx of our secant x, okay? So this is ddx of 1 over cosine x, so that's going to equal secant x times tangent x, okay? Alright, and the last one I'm going to do is ddx of cosecant. Again, I can't write here. Hold on. Okay, cosecant x. There we go. And this is going to be equal to negative cosecant x cotangent x. Okay, so we have 4 different formulas here for the derivative that you would be. It would be beneficial for you to memorize and know. Okay, for problems in the future. Okay, so that wraps it up for our video on trigonometric functions. I hope that helps, and good luck on your homework.